In this video, we will look at an introduction to matrix algebra. A matrix is a rectangular array of rows and columns of real numbers. We have the rows going this direction and the columns going this direction. When you're talking about a matrix, we want to think RC cola, rows by columns. We will name a matrix by the number of rows and columns. Rows always comes first and then columns. And that's called the order of a matrix. So to determine the order of a matrix, we want to look at how many rows there are by how many columns there are. So this has got 2 rows and 3 columns. So this is a 2 by 3 matrix. If we are adding matrices, matrices is the plural of matrix. So if we're adding matrices, the 2 matrices must be identical in rows and columns, and then we simply add the corresponding entries. So in this case, we'd have 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, 9, 11, and 13. And that is the addition of those 2 matrices. Scalar multiplication. When we're dealing with matrices, scalar just means the simple number as opposed to a matrix. So if we have scalar multiplication, we multiply. It's like distributive property. We multiply the number on the outside times everything on the inside. So we're going to get 3, 6, 9, 3 times 4 is 12, 15, 18. And that's our matrix there. Some more terms here. The zero matrix is any size matrix that is entirely of zeros. And the additive inverse of any matrix is the matrix that will add together with our matrix to give 0. So the additive inverse of this matrix would be -1, -6, -5, -2, +3, +4. So if we add these 2 together, we would get a 0 matrix. Matrix multiplication is a little bit more complicated. In order to multiply 2 matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. And I'll show you why. Because take this row and we multiply it by the columns. Let me show you how this works. We'll use this section on the left-hand side as our workspace, and we'll put the answer matrices over on the right. So we start with the first row and the first column, and we take it item by item. So first we do 1 times 1, we get 1. Then we do the second item by the second item. 2 times 2 is 4, and the third by the third is 0. So we add them all together. 1 plus 4 is 5. We repeat that first row, second column. 1 times 0 is 0. 2 times 1 is 2, and 3 times -1 is -3. 0 plus 2 minus 3 is -1. Now we move down to the second row. 0 times 1 is 0. 1 times 2 is 2. and negative 1 times 0 is 0. 0 plus 2 plus 0 is 2. Second row, second column. 0 times 0 is 0. 1 times 1 is 1. And negative 1 times negative 1 is positive 1, which gives us a 2. And there is our matrix, our answer matrix. So with matrix multiplication, in this case, we had a 2-row by 3-column matrix, and we multiplied it by a 3-row 2-column matrix, and we end up with a 2 by 2 matrix. So what you notice on this is whenever you do matrix multiplication, your answer will be the outside numbers. We have a 2 by 2 for our answer. We're going to do the same thing on calculator. So here's how we put things into the calculator. Matrix key is a second, so we go second matrix, and we move over to edit, and we're going to edit our A, and we tell it the size of the matrix, row by column, RC, so it's 2 rows by 3 columns. And then we can enter our numbers, 1, enter, 2, enter, 3, enter, and then it automatically goes down, 0, enter, 1, make sure you hit enter after each one, negative 1, enter. So there we have matrix A. Enter matrix B. We go back to second matrix. We need to go over to edit and down to B, and we tell this is a matrix. This is row by column, so we have 3 rows and 2 columns. 1, enter, 0, enter, 2, 1, enter, and negative 1. Now we have our 2 matrices entered in A and B, and now we can perform the calculations on them. So second and quit, we'll go out of this screen, and we go to second and matrix, and we'll get our A, and then second and matrix, and we'll get our B, and enter. So this is A times B. We get the same matrix as when we multiplied it out. What happens when we go B times A? We'll go second matrix B, enter, second matrix A, enter. If we do B times A, we get 1, 2, 3, 2, 5, 5, 0, negative 1, 1. Let's try this by hand. So if we're going B times A, we have our 3 by 2 matrix, and we're multiplying it by a 2 by 3 matrix. Those two must match, and we will end up with a 3 by 3 matrix as our answer. So we will start off, I'll go ahead and put our answer here, 3 by 3, and our workspace on the left. We start off with the first row, and then we'll go with each of the columns. So we'll have 1 times 1 plus 0 times 0, which will give us 1. So continuing with the first row and now the second column, we end up with 1 times 2 is 2, plus 2 times plus 0 times 1 is 0. 2 plus 0 is 2. And the last one, first row, third column, 1 times 3 is 3, plus 0 times negative 1 is 3. So we have 1, 2, 3 across the top. Now we're going to go to the second row. First column. 2 times 1 is 2, plus 1 times 0 is 2. Second row, second column. 2 times 2 is 4, plus 1 is 5. And second row, third column, which is 6 plus negative 1, which is 5. Moving down to the third row, 0 times 1 is 0, plus 0 is 0. That's 0 minus 1 is negative 1, and 0 plus 1 is 1. And that is the 3 by 3 matrix that we had on the calculator. You do need to know how to do it both by hand and by the calculator. So I'd like you to try these. Given these matrices, A is a 2 by 4 matrix, and B is a 4 by 2 matrix. I want you to find A times B, which should give you a 2 by 2 matrix. Use your calculator to check it. Then find BA. If we have BA, we have a 4 times 2 times a 2 times 4, which should give you a 4 by 4 matrix. And then secondly, try it with these two matrices. And now, just for fun, I want you to remember there's a fine line between numerator and denominator. See you in class.